More than a dozen craters lie in the desert south of Alice Springs, the largest about 180 meters across. But the missing piece is the witness. By the end of this story, you will know why scientists can measure the blast, weigh the iron, map the holes, and still be forced to listen to a warning carried without writing for roughly 4,200 years. This is the Henbury meteorite crater field and its living oral tradition. It sits about 145 kilometers south of Alice Springs, in the Northern Territory, where the ground looks dry, red, and almost quiet. Walk near the rims, and the place feels scraped open. Wind moves grit against your shoes, the heat presses on your neck. Nothing there looks soft. The familiar explanation is simple enough. A nickel-iron meteoroid came in fast, broke apart in the atmosphere, and struck with the force of a small nuclear blast. That is the science. Craters, metal, impact physics. But in 1931, when scientists first came to examine the site, their Aboriginal guide would not go closer. He said his people were forbidden from the place, and the reason was older than the expedition. If stories like this make you rethink what evidence can be, subscribe now, because the next part begins with the thing they said came down from the sun. That refusal matters because it happened at the edge of the evidence, before the place had been fully turned into maps, labels, and museum drawers. Picture the party moving across the red plain in 1931. Boots in loose gravel, tin canteens knocking softly, the air so dry it catches in the throat. Ahead of them, the crater rims rise and dip like old wounds in the ground. For the scientists, those rims were a problem to solve. For the guide, they marked forbidden ground. He did not need a laboratory to know the place had danger attached to it. His people had rules around it. They were not meant to go near. That is the point modern readers often miss. The warning was already there when the researchers arrived. There was no written impact report, no dated tablet, no European diary from the day the sky tore open. What existed was a boundary. Spoken and obeyed, held long enough to meet science at the crater's edge. When the local account was recorded, it described a fiery being, a fire devil from the sun, coming down so violently that it burned the land and made the holes. The uncomfortable part is this: that description begins to sound less like distance from science and more like a memory of impact physics. Once you hear the account beside the crater rims, the old words become difficult to ignore. A fiery thing comes down from the direction of the sun, the land burns, people are killed, holes are left in the ground. Those are not loose images floating around the desert. They line up, point by point, with what a fragmenting iron body would do when it entered the air at extreme speed. First, there is the light. A nickel-iron meteoroid does not drift down like a falling stone. It turns the air in front of it into a white-hot wall. If you were close enough, the glare would hurt the eyes before the sound reached you. Then comes atmospheric fragmentation. The body splitting apart under pressure, pieces racing ahead, each one carrying its own violence toward the ground. At Henbury, that matters because there is no single clean bowl. There is a field of impacts, more than one scar, more than one strike. The surface still holds the pattern of a body that failed in the sky before it finished falling. No photograph caught it. No written sentence from that day survives. But the ground says the object broke apart. And the tradition says something came down, burning, from above, and made the holes still visible under your feet. The metal becomes important because the holes alone could have fooled an early visitor. In the desert, round depressions can be blamed on many things. Old springs, salt pans, erosion, a strange collapse in the ground. But at this site, people found pieces of iron that did not belong to the local rock. heavy pieces, dark, dense, and cold in the hand before the sun warmed them. Some were scattered near the craters, as if the sky had dropped broken machinery across the plain. The material pointed to a nickel-iron body, the kind of object that can survive the fall better than ordinary stone. It also explained the pattern. Several craters, separate strikes, one broken visitor from space. The blast would have thrown dust outward, shaken the ground, and left a burnt, sharp smell in the air for anyone close enough to live through the first moments. Science could read the metal, the oral account could read the danger. Then the timing made the whole case more unsettling. It was roughly 4,200 years old, young enough to sit inside human memory if the chain of telling never broke. The next question is who saw it happen? The question changes the scale of the place. 4,200 years is ancient in a family story, but in the life of a crater, it is almost fresh. At Henbury, the rims have softened under wind, rain, heat, and time. Spinifex grows near the edges. Dust gathers in the low places. Lizards cross ground that was once blasted open. But the forms are still there. Wide enough to walk around, clear enough to measure, stubborn enough to contradict silence. This is where geomythology becomes more than an academic word. It asks whether a story can carry a real event through generations, especially when the event was loud enough, bright enough, and dangerous enough to change how people treated the land. Think about what has to survive. The first flash, the heat on skin, the sound arriving after the light, the shock in the chest. Then later, the rule, do not go there. Do not disturb that place. Remember why. There is no name for the first witness, no preserved camp, no object with a date carved into it. The crater field and its oral tradition meet in that gap. The gap is exactly where the warning becomes evidence. Evidence, in a place like this, does not always arrive in the shape science expects. A crater can be measured with a tape line. Iron can be weighed, cut, polished, and tested. The rims can be photographed from the air until the whole field looks like a set of dark thumbprints pressed into red earth. Those records are familiar. They fit neatly into reports. A warning is harder to file. It lives in who says it, who hears it, and what people do afterward. At Henbury, the warning had a job. It kept people back from a place linked with fire, death, and broken ground. Practical force matters. A story that only entertains can fade. A story that tells you where not to walk has a reason to survive. Listen to the pattern again. Bright descent. Burning land. People lost, holes made, then avoidance. The same sequence moves from sky to ground to memory to behavior. No preserved voice tells us the first version. No witness name is attached to the first telling. No camp remains have been tied directly to that day. But the rule was still alive when outsiders arrived in 1931, and that means the crater field was carrying more than metal. More than metal, because the physical site only explains the damage. It does not explain the obedience. Many scientific summaries can pass over that part too quickly. A crater is passive. It sits there. A warning acts. It changes footsteps. It tells people where to stop, where to turn away, where silence is safer than curiosity. At Henbury, that social fact survived long enough to be observed by outsiders. You can imagine the moment at the edge again, but now, with a different weight. The guide is standing in the heat, dust on his clothes, the hard smell of dry grass around him. Ahead are the rims the visitors want to inspect. Behind him is a chain of instruction older than anyone present. He refuses to cross it. That refusal is data about the place. Here is the careful line. Science does not need the tradition to prove an impact happened. The craters and iron already do that. The tradition does something else. It may preserve how the event entered human life as danger, loss, burning ground, and a command to stay away. If that command held for thousands of years, then the real archive was never only under the soil. It was walking beside the scientists and stopping before they did. That made Henbury more than a geological site. For decades, the easy version was to separate the evidence into two boxes. In one box, crater rims, iron fragments, shock, heat, and the clean language of impact science. In the other, an old account about fire and a place people avoided. The first box looked solid, the second looked harder to handle, but the desert does not divide itself that neatly. Stand near the crater field and the two records touch. The ground gives you measurements. The tradition gives you sequence. A thing descends. The land burns. People are lost. The holes remain. Then the place becomes dangerous to approach. You can almost hear the order of it in the crunch of gravel underfoot. This is why modern researchers in Aboriginal astronomy and cultural memory have treated Henbury with serious attention. The question is not whether iron fell. That part is settled. The question is whether the living account carries the human side of the same event. No instrument recorded the screams of the air. No camera caught the white flash over the plain. No written archive names the first person who looked up. Yet the warning survived. And it may have preserved the part the metal never could. The missing human side is where the mystery tightens, because the confirmed facts now leave a very narrow space for chance. The craters are real. The iron is real. The age is recent enough for human presence in the region. The impact force was large enough to terrify anyone within sight or hearing. It names descent, fire, death, and holes in the ground. Those details matter because memory changes, words shift, meanings gather around a place. But some events are so violent that they can become fixed points. A bright object falling in daylight, a blast rolling across open land. Dust rising where the surface had just been torn open, the bitter smell of burned grass. People afterward pointing to the scars and saying, "Remember this." Still, caution is part of the science. No one can prove the exact first words. No one can name the first person who saw the sky flare. No one can count what was lost that day. So, Henbury and its oral traditions sit in a rare position. The land confirms the event, while the story may preserve the experience. That leaves one final question. What do we call evidence when it has been spoken for 4,000 years? At the end of the trail, the answer is careful, but it is not empty. Science can confirm the craters south of Alice Springs. It can confirm the nickel-iron body, the breakup in the air, the blast, the scattered metal, and the age of roughly 4,200 years. It can show why one object became many holes. It can explain the violence in the ground. The living tradition can confirm something different. It carries a fiery descent from the sun, burning land, people lost, and a place that was treated with fear and restraint long after the flash was gone. What remains unknown is the first witness, the first telling, the exact day the sky turned white over that red plain. No instrument kept it, no page saved it, but at Henbury, the scar and the warning still face each other. The iron cooled, the rims softened, the rule remained. That is the image Henbury leaves behind, a guide stopping at the edge while the scientists walked forward, both of them holding part of the same event. If this story changed how you think about ancient memory and evidence, leave a comment below and subscribe for more buried histories that science is still learning how to read.